we're going to be looking at is something called a trigonometric identity. What a trigonometric identity is something that is always true. And there's some common ones that we've already learned. So at the bottom of your page there, go here, there, reciprocal identities. You already know that cosecant is 1 over sine, that secant is 1 over cos, that cotangent is 1 over tan. Beside this, I would like you to write, because you have some space beside, I'd like you to write also that sine theta is 1 over cosecant. Cos of theta is 1 over secant theta, and tan theta is 1 over cotangent theta. So you can either write cosecant as 1 over sine, or you can write sine as 1 over cosecant. We've also learned identities. You have that at the bottom. You also have, you know that tan is sine over cos, and cotangent is cos over sine. So with this, what's going to happen is they're going to say, these are the tools you can use. You'll have a certain number of identities that you know, and from that, you're going to prove new identities. And it's going to look like this. So I'm going to make up one right now, and I'm going to show you what these questions look like. These questions are going to look like this. Prove. And they're going to start off by saying, prove that sine of theta times secant of theta is equal to tan of theta. Is that true? Is that always true? How would you go about proving it? So the way that these proofs are going to work, and the rules and regulations that we're going to follow, is you're only allowed to work on one side at a time. Because we want to prove that these are equal, we're not allowed to assume they're equal before we prove them. So the first step that we're going to do is we're going to draw a line where the equal sign is. So that nothing can go over the line. You can't move one, it's not an equation yet because you haven't proved that it's true. So you can't add 5 to both sides. Because if you add 5 to both sides, you're assuming something's true to begin with. And that's what we've been asked to do. We've been asked to prove that this is always true. So to start with, we're going to take some of the little identities that we already know and say, what could I change? What could I change in this equation that I know from my identities? I could change the secant. What could I change the secant to? 1 over cos theta. So then I could say, well, I know that secant is equal to 1 over cos. Now, how do I multiply fractions? Do you need a common denominator for multiplying fractions? No. How do you multiply fractions? Multiply across. So I can make this over 1, right? And then this would equal sine theta over cos of theta. So I changed the secant theta to 1 over cos. And then I wrote it as a single fraction, because a lot of the times you're going to want to write things as a single fraction. Am I closer? They're not the same yet, but what can you change? You know that this is another one of our mini identities, right? Sine theta over cos theta is equal to tan theta. And so our goal, these are like mini puzzles. Our goal is to try to make the left-hand side equal to the right-hand side. There's many different ways you can do this. This was one of them. And as soon as you get the left-hand side equals to the right-hand side, you'll write a little statement to say you're done. Therefore, the left side equals the right side, and you're done. If you want to use the fancy Latin way to show that you're done a proof, you can write QED at the end. It stands for, my Latin pronunciation is probably going to brutalize this, but quod erat demonstratum, which means what has been asked for has been demonstrated. Sounds fancy? Okay. The other thing you sometimes see in textbooks when they're done a proof is a little, I like to draw a little box and shade it. That's what I did in university. Sometimes you see, like at the end of a Maclean's article, when the article ends, they put like a little maple leaf with an M in it. So there's different things that different books and different things use to show that something has ended. So by doing QED, you've said, I'm done. I like to draw a little box and do some shading just for fun. You can do that as well. You don't need to, but you need to end with, therefore the left-hand side equals the right-hand side. And if you want to put QED, you can. If you want to do the little shaded box, you can. But that's all you have to do. You could have also finished this one. Say you got to sine over cos, and you say, hey, I know what tan is equal to. I can change tan. And you could go on this side to change this side to sine over cos. And then the left side is equal to the right side. So you don't have to only work on one side. You can work on both sides. But as soon as they get to be identical, then you're done and you've proven it. That's the idea. Now I've got a bunch of these for you. I'm going to hand out a sheet to you right now. They start off easy and they get more and more complicated as you go. What we're going to do in this unit is we're going to start off with the easiest strategies, and you're going to get to a point where you get stuck. And then I'm going to have to introduce some other strategies. And then you're going to get to a point where you get stuck. And they get more and more complicated as we go. But they're going to start off really easy, and we're going to work on some right now.